The engineering of Sydney Metro Northwest introduction. The challenge of urban mobility in the early 21st century, cities worldwide faced a significant challenge: urban mobility. With populations growing in densely populated areas, the need for efficient transportation systems became critical. Sydney, one of Australia's largest cities, was no exception. Traffic congestion and strain on existing rail systems plagued commuters, harming economic productivity and raising environmental concerns. In response to this urgent need, the New South Wales government initiated the ambitious Sydney Metro Northwest project, aiming not just to alleviate commuter strain, but to transform the integration of urban transport into city life. Context, time, place, and need. The Sydney Metro Northwest project officially launched in 2015, marking the first key phase of the broader Sydney Metro system, with roots dating back to the early 2000s. Rapid population growth in northwest Sydney, notably in areas like Rouse Hill, highlighted the necessity for an efficient transit solution. By 2031, this region was expected to accommodate around 130,000 residents, up from 50,000 just 10 years earlier. Existing transport systems, reliant on roadways and outdated rail lines, struggled with the anticipated increase in commuters. Commute times often exceeded an hour, while public transport options outside the Sydney Central Business District were limited. A new metro service was proposed to foster economic growth and improve quality of life by providing direct access to the city. The engineering challenge. Engineering a metro system like Sydney Metro Northwest required overcoming various challenges due to the city's geography and urban environment. Essential was the alignment with existing infrastructure, minimizing community displacement, and ensuring efficiency and sustainability. A collaborative approach, blending civil engineering, structural design, environmental science, and community planning, was necessary. The project faced obstacles from Sydney's hilly terrain and limited construction space. Existing residential and commercial zones also constrained design options. The team aimed to create a largely underground system to reduce disruption and utilize advanced tunneling technology. Step-by-step explanation of the solution, planning and design, extensive site assessments and feasibility studies began the project. Analyzing geological data and transport flows, engineers used sophisticated modeling to predict how the metro could effectively serve the growing population. The final plan proposed a 23-kilometer underground rail line connecting Tallawong Station in the northwest to Chatswood Station in the east. This design maximized commuter access while preserving community spaces. Tunneling technology. Construction relied on two large tunneling machines named Nancy and Mabel, each weighing about 1,500 tons. These machines, designed for Sydney's varied geology, excavated while supporting tunnel structures. Operating on rotary cutting principles, the tunnel boring machines enhanced safety by minimizing surface disruption and reducing road traffic delays. Engineers adapted techniques to address unforeseen geology and groundwater issues, particularly near Sydney Harbour, ensuring optimal TBM performance. Stations and infrastructure. Building 6 new metro stations was critical. Each station focused on functionality and community engagement, equipped with modern safety features and advanced technology. Stations facilitated smooth transitions between transport modes, with high-level platforms for quick boarding and accessibility features for all users. The implementation of a smart transportation system enabled real-time monitoring and efficient train operations. Difficulties and breakthroughs. Technical capabilities were only part of the project. Community engagement was equally important. Residents raised concerns about noise and construction timelines, prompting mitigation strategies including workshops and noise-reducing technologies. As the project progressed, engineers revisited environmental impact assessments, integrating feedback. Commitment to sustainability included solar panels and energy-efficient systems, reducing the carbon footprint of the new metro line. A significant breakthrough involved reusing excavated soil for landscaping, minimizing environmental impact and costs. Real-world impact and significance. The Sydney Metro Northwest opened in April 2019, initiating a transformative era for public transport in Sydney. The system, praised for efficiency, featured trains running every 4 minutes during peak hours, significantly easing car reliance and reducing congestion. Statistics indicated increased ridership and cultural shifts towards sustainable commuting, positively affecting emissions and local businesses. Enhanced access boosted foot traffic and economic opportunities for residents. The project set a benchmark for future urban transport initiatives in Australia, demonstrating that large-scale engineering can prioritize community engagement and sustainability. The Sydney Metro Northwest exemplifies how modern metro systems can enrich urban living by seamlessly blending transport with community life. Reflective closing, the engineering achievement of Sydney Metro Northwest highlights advanced technology, meticulous planning, and stakeholder engagement. As global cities face similar transport issues, Sydney's experience offers essential insights into balancing urban functionality, community needs, and environmental responsibility. This project signifies a pathway to enhancing urban transport systems that promote growth and sustainable living, ultimately improving residents' quality of life. The Sydney Metro Northwest stands not just as an infrastructure milestone, but as a model for cities aiming to innovate in a rapidly evolving world.